Gaia is often referred to as the Gaia hypothesis, the Gaia theory, or the Gaia paradigm, depending upon who's speaking about it. I'm not going to take any position on that. Simply put, and quickly, we can say that Gaia is the planet Earth. The Earth consists of a number of living organisms and inanimate materials, water, crust, and so forth. If we take all of the living organisms and the ecosystems on the planet together with the inorganic material, we get one living organism, referred to as Gaia. A human is an animal, a type of organism. A tree, also an organism, any kind of plant. Animals, such as humans, have various organs. And the organs have certain functions, and there are interactions between the various organs in the body to achieve other kinds of functions. Each organ consists of various cells, some of them with various specialized functions. Together, we see the various parts that become an organism. The idea here is that it's very similar with Gaia. All the various different parts, if we view it at a distance, looks like an organism. Now, humans are complex and consist of a variety of different parts. Sometimes it can be a little difficult to decide where the human body ends and where something else begins. For example, we have microbes in our gut, and these help us with the digestive processes, but they're also integral to the immune system. Are they parts of our body, or are they something else? Are these bacteria in a symbiotic relationship with the rest of the human body? What is the relationship here? It could depend a bit upon who you are, how you view this, but let's just see that the similarity with the idea of Gaia, where does one ecosystem end and another begin? Where does part of Gaia is living and going over to inert materials that can be resources in the rocks and so forth, end and begin? A similar kind of idea. James Lovelock and Hollyland Margulis were the co-developers of the concept of Gaia. But as so often happens in the natural sciences, it's the male scientist who gets most of the credit for this. On the other hand, it's usually assumed that it was Lovelock that had the original idea, but then he required working with Margulis to be able to actually achieve greater understanding and further develop the idea. Regardless, just like in the same way that Kreutzen was one of the people that has popularized and made the Anthropocene more well known and has been a champion for the term, it's the same thing with Lovelock. He put a lot of energy into writing books and articles and being interviewed about the Gaia hypothesis, theory, paradigm, whatever you want to call it, whereas Margulis's professional development took somewhat different directions. I'll have to stop this here now because otherwise this video lecture will turn into something else other than the idea of talking about Gaia and not about discrimination and gender gap and so forth in the sciences and in academia. According to Lovelock and other researchers who have followed in his footsteps, there are multiple strands of evidence that support the Gaia hypothesis or the Gaia theory. Prior to the Industrial Revolution, the Earth, or that is to say Gaia, has been exposed to a number of external shocks. Of course, things became very dire about 66 million years ago when a meteor or an asteroid about 10 kilometers in diameter struck the Earth near where present-day Yucatan Peninsula is in Mexico. It would appear that most dinosaurs became extinct quickly after this, and it would be some time before new species of plants and animals evolved to fill new niches. However, following each disturbance that has occurred to Gaia because of an external shock or because of emerging properties in Gaia leading to some sort of internal conflict, despite these, Gaia survives intact, and after some time, a new system arises. New exosystems in various places around the world that together form Gaia. On Gaia, a number of feedback mechanisms help form stability in the short term. As advocates of Gaia suggest, if we study individual ecosystems, we can see how there are various feedback mechanisms which tend towards stability. Also, if there's an accumulation of something, then there are some other effects that might reduce the accumulation. We see the relationships between predator-prey microorganisms are changing in a dynamic way, leading to, in the long term, a tendency for stability. They argue then that we can see that the same thing applies to the entire planet. The sum of all ecosystems together function as one organism. Coevolution builds upon the original idea of evolution. Originally in evolution we understood that a particular species evolved based on what is happening in the surroundings. But with coevolution, the tables are turned. The species can influence its surroundings. And if we take several species together, their impacts on the surroundings might be enough, given enough time, that even abiotic parts of the earth, rocks and other matter like that, could be influenced by life itself. This is coevolution. Life forms evolve because of the changing surroundings, but they themselves influence the surroundings. In this light, Lovelock informed NASA in the 1960s and 1970s that if you're going to Mars to look for life, I can tell you there is no life there. Why could he say that? He could look at the atmosphere, and there had been measurements of the atmosphere on Mars done from Earth, and a long time prior to space probes, and now, in this century, rovers on the planet. Based on the observations of the content of the atmosphere on Mars before, Lovelock and others could say there's not going to be any life there. Because if there was life, microbial life, similar kinds of form of life, that had existed for millions and millions of years, we would have seen some sort of trace gases coming from those life forms, their waste and so forth, in the past, for millions of years. And this would give rise to changes in the atmospheric composition, which would be observable from the planet Earth. Now, needless to say, this didn't make Lovelock all that popular with some people at NASA, because the mission, of course, with NASA was to investigate other planets, and here's somebody saying, don't bother going there, there's no life. You might want to go there for other reasons, but not for trying to find life. Now it will be beyond the scope of this video lecture presentation to talk about all the details of Gaia and the examples that advocates of the Gaia hypothesis or the Gaia theory cite as examples of some sort of self-supporting planetary system, Gaia. But we know that millions and millions of years ago that there was extremely little oxygen in the atmosphere. The amount of oxygen began to increase because this was a byproduct of some forms of life. And now we are in the modern era, this period of time in human history, but also in the history of the Earth, where the atmosphere is approximately 21% oxygen. This didn't happen overnight. This was the end result of a series of changes caused by life that increased the amount of oxygen in the atmosphere. Now, the 21% of the troposphere, the lowest level of the atmosphere, is oxygen. And given enough time, some of that oxygen works its way up into the stratosphere. And some of that oxygen gets hit by ultraviolet light, and the free oxygen combines with O2 oxygen and forms ozone. And so with an increase in the amount of ozone in the stratosphere, we have some sort of protective blanket over the planet that blocks out a lot of UV light. We wouldn't have had an ozone layer if it hadn't been for forms of life that increased the amount of oxygen in the planet, increased the amount of oxygen in the troposphere. So that effect by life affects the atmosphere. Given enough time, we have an ozone layer, and that in turn makes more favorable conditions for certain kinds of life on the surface of the planet Earth and in the upper layers of the ocean. So in slow, and sometimes a little faster, and sometimes subtle and not so subtle ways, the Earth continues to change. Sometimes we reach tipping points because of internal contradictions in the emerging properties of Gaia. On the other case, we have external shock events like meteor crashes and so forth. The end result is that the Earth may sometimes flip from one kind of stability to another form of stability, but life in Gaia is preserved and continues to grow and thrive. Lovelock would point to the relative stability of the Quaternary period, which is the period in geological history for the last 2.5 million years or so. We'll say 2 million years. This is the period of time when we have had repeated ice ages, punctuated by short periods of time which will be called interglacials, when the world has become warmer. Prior to the Quaternary period, we had a much warmer kind of planet. So what we see is that through various feedback loops, that the ice ages expand, the continental ice sheets expand, and then at some point they contract. This could have to do with external effects. It can also have to be the inherent nature of Gaia itself. The Quaternary period is divided into two epochs. The first is the Pleistocene, which is the which is the longest period of time during the Quaternary period. This was up until about 11,700 years ago, or so, when we have the Holocene. The Holocene was when the end of the last great period of glaciation occurred and the continental ice sheets began to retreat from parts of North America, Eurasia, and other locations around the world. And we begin to enter a period of time when human civilizations arise. So the Holocene is the entire period of time from the end of the most recent ice age until now. And that is the period of time where there's been the debate whether we have now entered the Anthropocene. The Holocene would be ending and the Anthropocene would be beginning at some point in recent history, or some hundreds of years ago. And even though the ICS has decided against adopting the Anthropocene, we still have the idea and its validity. It turns out that the Gaia hypothesis, or the Gaia theory, or the Gaia paradigm, however you want to call it, is a bit controversial for some scientists, although it's not controversial for others. The primary reason for controversy on the part of some natural scientists has to do with the lack of sufficient evidence. It's thought there is insufficient evidence to be able to prove the Gaia hypothesis and therefore turn it into a Gaia theory, so to speak. This line of thinking does not deny coevolution, that one species that evolves and its emerging properties begin to affect other kinds of species. However, the reason for not accepting Gaia has primarily to do with that it cannot be seen that this is taking place on the scale and the time scales that Lovelock and others have been suggesting. The second reason for controversy and not acceptance, or just controversy, is that Lovelock and others, through their writing, their interview, and so forth, have, shall we say, infused an almost spiritual kind of quality into this natural science concept. Perhaps Lovelock later in his life would have distanced himself from that. But there's almost a mystical or religious kind of quality to this self-regulating organism. And to choose a Greek goddess, Gaia, to give it that name is also suggestive of the need, or the sort of adding in religion or spirituality into a natural science concept. This is rather difficult for some in natural sciences. They and predecessors of them have been spending decades and hundreds of years of trying to remove the religious and the emotional and the irrational from society and from natural science. And here we have James Lovelock in the 1970s and 1980s and onwards adding in some sort of spiritual dimension to this very fundamental natural science kind of concept. And that, some people view, as something is very suspicious about that. On the other hand, there have been scientific gatherings and conferences that have been held with the sole purpose of discussing Gaia to try to change its status from being a hypothesis into an accepted scientific theory. And for those that have attended such conferences and have agreed to that, then, well, Gaia is a theory and not just a hypothesis. In this lecture, I'm not taking any sort of position for and against whether Gaia is a hypothesis or a paradigm or a theory, but it certainly is an idea that we need to have consider when we're thinking about the entire planet and human activities on the planet. Bruno Latour, in some of his writings, speaks about the need for Gaia to be better understood. In fact, he suggests that one of the reasons why we have a number of contemporary environmental problems at this time is the fact that Gaia as a concept, theory, hypothesis, paradigm, whatever, has not been accepted enough in society. He postulates and argues that with Gaian thought and practice we would have fewer or different kinds of environmental problems. He looks to other fundamental concepts and changes in our understanding of the world and the universe, such as Cartesian geography, Newtonian physics, Darwinian evolution, Einsteinian relativity, and similar kinds of fundamental concepts. And he says that Gaia should be placed at least on a similar kind of level there. Since the Gaian perspective has not been able to be affect in science and society as much as he suggests it would be possible there, this will suggest that we're going to be stuck with a number of environmental problems for the time being. And in fact, given how evolution is being actively worked against in the United States of America, in some states there, where the theory of evolution is being removed from school textbooks in biology and other areas, that doesn't seem like there's all that much hope for Gaia in the future. And I think this, from a more social science perspective, mirrors some of the natural science perspectives and pessimism that exists among, say, climate researchers. However, Gaia is still an important concept to understand and think about, and to see how it's related both to the Anthropocene and to planetary boundaries.